Today, we're diving into the intriguing world of environment-aware malware, a sophisticated threat designed to evade traditional cybersecurity defenses. This malicious software only activates when it detects it's in a real, target environment, cleverly bypassing sandboxes and analysis tools. It achieves this by checking various system characteristics, essentially fingerprinting its surroundings to determine if it's being observed. Malware can examine RAM size, CPU cores, hard disk space, and even specific device drivers to identify virtual machine-like specifications. It also scans for the presence of analysis tools and debuggers, such as Procmon.exe or Wireshark.exe, which are common in security labs. Registry key checks are another method, searching for entries associated with virtualization software like VMware or VirtualBox. Network environment checks help detect fake internet or proxy setups often used in isolated sandbox environments. Some malware waits for user interactions, like mouse movements or keyboard input, before activating its malicious code. Timing-based evasion allows it to delay execution or limit its activity, avoiding analysis within typical sandbox timeframes. Advanced malware can even perform geolocation checks, refusing to execute if specific language settings or IP locations are not found. If a sandbox is detected, the malware might terminate, remain dormant, or mimic benign behavior to deceive analysts. This split personality makes it incredibly difficult for traditional sandboxes to accurately assess the malware's true capabilities. Traditional sandboxes often fail because the malware recognizes the artificial environment and simply avoids triggering detection mechanisms. To counter this, security professionals employ more sophisticated techniques, starting with layered analysis. Advanced sandboxes are configured to closely resemble real-world systems, complete with faux programs and files to mimic typical user environments. These sandboxes include evasion resistance techniques, such as emulating real user activity and hiding virtualization indicators. Behavioral analysis monitors and logs every action taken by a suspicious file, including file system modifications and network communications. Machine learning algorithms are also used to identify patterns and anomalies in system behavior that indicate malware presence. Memory dump analysis extracts indicators of compromise and detects advanced malicious behaviors like privilege escalation. Some sandboxes even use deception techniques to lure malware into revealing its full functionality, providing deeper insights into threats. Examples of environment-aware malware include the Configure worm, which famously avoided Ukrainian machines, and MiloBot, which uses timestamping to detect patch sandboxes. Win32/Copter checks system uptime, and Vidar Stealer uses packers and environment checks to block automated analysis. The ongoing arms race between malware developers and security professionals means new evasion techniques are constantly emerging. By understanding how environment-aware malware operates and implementing advanced detection, organizations can improve their defenses. Staying ahead of cybercriminals requires continuous vigilance and adaptation in our cybersecurity strategies.